All right, day 3. So you might notice that I'm a little bit more zoomed in closer. I just want to make sure that you guys can hear me. I did all these videos and I forgot to test out how the sound went. And I just want to make sure that you guys can hear me. So I moved the iPad a little bit closer. So if I'm zoomed in, okay, if you can see all the gray hairs on my chin, I apologize. Okay, just want to make sure you can hear me. All right, so moving on. What is trigonometry? Well, I'm going to break down the word. Trigo is referring to triangles, and metry refers to measurements. I don't know what the no part is. I don't know why it's not just trigonometry, but it's trigonometry. Maybe because it sounds cooler that way. But the point is, if trigo means triangles and metry means measurements, then trigonometry literally translates to the study of triangle measurements. That's all it is. Way really quick. But in particular to this class, I just want to make it clear that even though trigonometry is the study of triangle measurements, not just right triangles, but all triangles, obtuse, acute, scalene, equilateral, isosceles, and so on and so forth. I just want to make it clear, we're going to be focusing mostly on right triangles in this course for trigonometry. So mostly right triangles in this class. Okay, just give you guys time to look it over. I would be asking if anybody has any weekend plans, but I'd just be talking to myself. Okay. So, previous to that, I just want to make sure that we have enough space. So, if you guys need time to copy this down, go for it. Pause. Okay. So previously, we had learned the 3 trig ratios. Three trig functions. I'm going to call them functions from now on, if I can. Otherwise, the 3 trig functions are sine, cosine, and tangent. And we abbreviate them with the calculator button, sine, cosine, and tangent, as the sine of an angle theta, the cosine of an angle theta, and the tangent of an angle theta. Sin, cos, tan, but in other words, sine, cosine, and tangent. That's how we abbreviate them. Okay, let's just go over the definition of them. Okay, so sine, so first off, let me just draw a triangle. That'll make life a little bit easier. This is my first time filming, so zoomed into the camera. Okay, so if I draw a generic right triangle with side lengths A, B, and C, so let's call this angle theta, and these are side lengths A, B, and C. A squared plus B squared equals C squared to satisfy the Pythagorean theorem. So in this case, the sine ratio, the sine of angle theta, refers to the ratio of the opposite side of angle theta compared to its hypotenuse. So the sine ratio is known as, you take an angle, look at its opposite side, and compare it to its hypotenuse. That is called the sine ratio. And let me just make that a little bit Okay? The cosine of angle theta is the ratio of an angle's adjacent side, adjacent meaning next to, such as I am adjacent to the whiteboard. Adjacent side of theta compared to the hypotenuse. The tangent of angle theta, which some of you guys are smiling because you guys already know the formal definition of tangent from the previous unit, but remember that the first definition that I gave you is that the tangent is referred to as the ratio of an angle's opposite side to its adjacent side. Luckily, there's a mnemonic that helps us remember these three trig ratios and what they stand for. And what I like to do is draw this little diagram on the side. Soh, kah, toa. And I always pronounce the H, so I remember that the sine and cosine have the hypotenuse in them. So pronounce the H whenever you pronounce soh, kah, toa. I went to high school with a lot of people who pronounce it SOHCAHTOA. Okay, give you guys time to absorb all that information. So in this diagram, if I look at angle theta, the opposite side of angle theta is A, the adjacent side of angle theta is B, and the hypotenuse of the triangle is C. So the sine ratio of angle theta is A to C. The cosine, the adjacent over the hypotenuse, is the adjacent side over its hypotenuse, so the cosine of angle theta would be B over C. And the tangent, which is the opposite side of angle theta over the adjacent side of angle theta, TOA, the tangent of angle theta is A over B. So let's get some specific examples in, and I'll show you what I mean. Okay, so now, let's say I draw two generic triangles. And let's say one of them is the basic example. Let's go with 3, 4, 5. Let's put angle theta right in the corner. So what I'm asking for is, look at angle theta, find the sine, cosine, and tangent for angle theta. So if it helps to put SOHCAHTOA, go for it. So what I'm going to do to find the sine of theta, soh. I look at angle theta. What's the opposite side of angle theta? The opposite side of angle theta is 4. The hypotenuse of the triangle is 5. Opposite side over hypotenuse, 4/5 is the sine ratio for angle theta. Let's look at the cosine of angle theta in this diagram. Cosine. So we're going to look at the adjacent side of angle theta. Notice that the hypotenuse is 5, so the adjacent side is the side length that is not the hypotenuse, but next to. So the adjacent side of angle theta is 3. The hypotenuse of the triangle is 5. So the cosine ratio for angle theta is 3 over 5. Now, let's go on to the tangent of angle theta. The tangent of angle theta in this diagram, TOA, that's the ratio of an angle's opposite side to its adjacent. The opposite side of angle theta is 4, the adjacent side of angle theta is 3, so the tangent ratio of angle theta would be 4/3. Sine of theta, cosine of theta, and tangent of theta in that diagram. See if you can do problem number 2 on your own. I want you to find sine, cosine, and tangent for angle theta. Just make that a little bit neater. Let's say I put angle theta in the corner, right there. Find sine, cosine, and tangent for angle theta. Well, here we go. So the sine ratio is the opposite side to its hypotenuse. So let's look at the angle. Draw a straight line like a bow and arrow. What is the opposite side of angle theta? That would be 12. What is the hypotenuse of the triangle? That would be 13. So the sine of angle theta is 12/13. The cosine of angle theta is the adjacent side of angle theta to its hypotenuse. So what is the side that is adjacent to angle theta? That would be 5. 5 is adjacent to angle theta, and 13 is the hypotenuse. So 5/13, we've got so, we've got ka, and now we're going to do toa, tangent. The tangent ratio for angle theta. I'm going to look at angle theta. The tangent ratio is the ratio of an angle's opposite side to its adjacent side. The opposite side of angle theta is 12. The adjacent side of angle theta is 5. So the tangent ratio of angle theta would be 12/5. Okay. Moving on. Now, we are going to come back to these exact diagrams. So I want to make sure that you guys understand what I'm gonna incorporate next. I just want to make sure I have enough board space. Okay, so a little bit to the side. Now I want to cover the 3 reciprocal trig functions. So earlier in the school year, I said that there were 3 trig ratios in your calculator, and I was right about sine, cosine, and tangent. Okay, let me just move that to the right a little bit. 3 reciprocal trig functions. Okay, then I'm going to introduce 3 more. The 3 reciprocal trig functions go as followed. You've got cosecant, secant, and cotangent. Believe it or not, if you know sine, cosine, and tangent, this isn't too bad. Because what does the word reciprocal really mean? Go back to middle school where you had to divide fractions. You divide fractions by multiplying the second fraction by, multiply by the second fraction's reciprocal, or flip it. So the cosecant can be abbreviated as CSC of theta, so the cosecant ratio of angle theta. The secant ratio can be abbreviated with SEC of theta, secant of theta, and the cotangent of angle theta would be COT, the cotangent. But what is it equal to? the cosecant of theta is no different than the reciprocal of sine. Just want to make sure that the board can see it. Oof, nope, cannot. So the reciprocal of cosecant, cosecant is nothing more than the reciprocal of sine. And by that logic, the secant of angle theta is 1 over cosine, the reciprocal of cosine. And cotangent is the reciprocal of tangent. So using that, it's not going to be so bad to be able to do the 6 trig ratios for these diagrams. We just put 1 and 2 accordingly, just so they all fit. Okay, so going back to problem number 1, now that I know sine, cosine, and tangent, can I figure out their reciprocal trig functions for angle theta? Well, over here, we want to figure out cosecant of theta, secant of theta, and cotangent of theta. Remember, cosecant is the reciprocal of sine. So what's the reciprocal of 4/5? The reciprocal of 4/5 is 5/4. Therefore, the cosecant of angle theta is 5/4. The secant is the reciprocal of 3/5. Secant is reciprocal of cosine of theta. So the secant has to be 3/5. 5/3. And finally, the cotangent of angle theta is the reciprocal of tangent of theta, or the reciprocal of 4/3, which is 3/4. So we have found all 6 trig ratios for angle theta. See if you can find the cosecant, secant, and cotangent for problem number 2. So, the cosecant of angle theta, let me just make a little divider right there. The cosecant of angle theta in problem number 2, we flip the sign, 13 over 12. We look at the secant of angle theta, and that is the flipped version of the cosine ratio, or 13 over 5. And finally, the cotangent of angle theta is the flipped version of the tangent ratio, or 5/12. By the way, feel free to email me with any questions, because I know it gets confusing. Okay. I'm going to pull up the next few problems. Sorry about that. I'm multitasking. I'm literally uploading another video at the same time. Okay. So let me get these problems ahead of you. So the directions are going to say evaluate the 6 trig ratios for the following triangles. Okay. Okay, so we get that there for you. 25, 45, 51. Sorry if it's not drawn to scale. Right, and let's put angle theta right here. Find sine, cosine, tangent, cosecant, secant, and cotangent for that triangle. And when you're done, you can do this 15, oh sorry, that should be a 24 by the way, sorry about that. You can check the Pythagorean theorem, that'll work. 24 inches, 45 inches, 51 inches. And finally, 15, 36, 39. Actually 7, 24, 25. Okay. Do these problems independently. Okay. So now, soh ka toa. So I like to put this up there just to remind myself. Soh ka toa. And then cosecant, secant, and cotangent are just the reciprocals of these. So the sine of angle theta in this diagram is opposite over hypotenuse, or 24 over 51. The cosine of angle theta in this diagram is the adjacent to its hypotenuse, or 45 over 51. The tangent of angle theta would be opposite over adjacent, so that'd be 24 over 45. Okay, and finally, on the other side, let's find the reciprocals, the reciprocal trig identities. Cosecant of theta, secant of theta, cotangent of theta. The reciprocal of the sine ratio would be 51 over 24. The reciprocal of the reciprocal of cosine would be the secant ratio, or 51 over 45. And finally, the tangent ratio has a reciprocal called cotangent, which is 45 over 24. Okay. Finally, on number 4, we're going to figure out the sine, cosine, and tangent, and the cosecant, secant, and cotangent. So the sine of angle theta, looking at the theta, we've got 24 over 25. So, ka, the cosine. The adjacent side of angle theta is 7. The hypotenuse of the triangle is 25, so the cosine ratio is 7 over 25. The tangent of angle theta would be the opposite side over its adjacent side, so that'd be 24 over 7. Just make sure it fits in the, it fits. All right, so finally, last thing, and then you can enjoy your weekend. Cosecant of angle theta would be the reciprocal of the sine ratio, or 25 over 24. 25 over 24. And the secant is the reciprocal of the cosine ratio, which should be 25 sevenths. And finally, the tangent ratio has a reciprocal trig identity called cotangent of angle theta, which is 7 over 24. Okay. Have a wonderful weekend. I will see you on Monday.